Hi, good evening and welcome back. We are on the last lesson for solving quadratic equations. This is lesson 16.6. This deals with solving quadratic equations by using a quadratic formula. Okay, so I have a formula. I'm going to straight away use that formula to get the values of x. Okay, so I have this quadratic formula. It's very important that you memorize this formula. This formula, you can, if you go to YouTube and you just type in or Google and type in quadratic formula songs, it will give you a lot of YouTube videos where people have created songs for it, for you guys to use those songs to memorize the formula. This formula will not be given to you on the reference sheets on your EOCs. It's a very important one, and you will be using it even in algebra too. So it's, and also in geometry, I think. So it will be very useful if you guys know this formula by heart. So there are a lot of songs. You can use those songs to help you memorize this formula. All right. So I have this quadratic formula which straight away is going to give me the values of x. The two values of x arise from that plus or minus. So I have negative b plus or minus square root of b square minus 4ac all over 2a. That's my quadratic formula. It's simple to use the formula. I have this quadratic equation written in standard form, ax squared plus bx plus c equal to 0. So to use the quadratic formula, I have to have my quadratic equation written in that form. So when can I use this method? Always. You can use this always. All right. All that is required is for you to know your a, b, and c. You can go ahead and plug it into the formula and simplify it. You will get your values of x. So step 1 is for you to put your equation in standard form. Make it look like ax squared plus bx plus c equal to 0. Set it to 0. Then step 2, find out what your a, b, and c are, including the sign. Don't miss it. Very important. And then step 3 is plug those a, b, and c values into the formula and simplify. We're going to be using PEMDAS, order of operations, to simplify the formula once you plug it in. So straight away, let's get into a problem, solving a problem. So I'm given this equation, 2x squared plus 3x minus 5 equal to 0, using quadratic formula. So when I look at my equation, it is already written in standard form. If things are jumbled up, you need to write it in this form, ax squared plus bx plus c equal to 0. Now I know a is 2, b is 3, and c is negative 5, right? So all I do is take that and plug it into my formula. My formula is x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So x equal to negative b is 3 plus or minus square root of 3 squared minus 4 times a times c all over 2a, 2 times a. So x equals negative, I'm going to use PEMDAS, order of operations. Whatever is under the square root can be simplified separately. This can be simplified separately. This can be simplified separately. And then I can bring them all together. This negative of 3 is negative 3 plus or minus square root of, what's under the square root? Exponent. 3 square is 9 minus 4 times 2 times negative 5. So 2 times negative 5 is negative 10. 4 times negative 10 is negative 40. So that's negative 40. All over 2a is 4. So x equals negative 3 plus or minus square root of negative is going to give me a positive. So 9 plus 40 divided by 4. So negative 3 plus or minus square root of 49 divided by 4. I have to square root the 49. X equals negative 3 plus or minus 7 divided by 4. So now after this step, I'm going to split it into two values of x. The first value of x is negative 3 plus 7 divided by 4, and the other value is negative 3 minus 7 divided by 4. So negative 3 plus 7 is going to give me x equal to 4 over 4, which will be 1. And in this case, x will be equal to negative 10 over 4, or it's negative 5 over 2. So the two values are x equal to 1 and x equal to negative 5 over 2. So you got your two values of x just by plugging the values of a, b, and c into your formula after writing the equation in standard form. So let's take a look at this equation. Solve 5x plus 2 equals 3x squared by using quadratic formula. So as you can see, this is not written in standard form. To write it in standard form, I have to set one side to equal to 0. So either I can move the 3x squared over here. If I move, I have 5x plus 2 equal to 3x squared. I could either move the 3x squared over there. So I will get negative 3x squared. Remember, the ax squared terms comes first. Plus 5x plus 2 equal to 0. And then I can list my a is negative 3, b is 5, and c is 2. And then use it in the formula. Or I could move the 5x and the 2 over with the 3x squared. That way I could make this side to a 0. So I can subtract the 5x, subtract the 5x, should subtract the 2, subtract the 2. So I get 3x squared minus 5x minus 2 equal to 0. Now a is 3, b is negative 5, c is negative 2. You are welcome to solve this using these a, b, and c, or you could solve it using this a, b, and c. I'm going to use this one because I have a negative number for b. I want to show you what will happen in the formula. Okay, you are more than welcome to try using these values. You should get the same values for x. So I have my x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So negative of, this is in the formula, right? That minus sign. B is negative 5. So b is negative 5 plus or minus square root of b squared is negative 5 squared minus 4 times a times c all over 2a. Alright, I chose these values just to show you I have a negative b. What will happen? So negative of negative is going to change it to a positive. Plus or minus square root of negative 5 squared is 25 minus 4 times 3 times negative 2. 4 times 3 is 12. 12 times negative 2 is negative 24. Divided by 2 times 3 is 6. So I have x equal to 5 plus or minus square root of 25 plus 24 divided by 6, which will give me x equal to 5 plus or minus square root of 49 divided by 6. The next step would be x equals 5 plus or minus 7 divided by 6. Now from this step onwards, I want to split into two values. X will be 5 plus 7 divided by 6, or x equal to 5 minus 7 divided by 6. This would give you 12 over 6, which is 2. This would give you x equal to negative 2 over 6, which is negative 1/3. So the two values are x equal to 2 and x equal to negative 1/3. Okay, so if you use these values for a, b, and c, you should still get the same values for x. Alright, so that's using a quadratic formula. This quadratic formula comes handy in another thing. Okay, so we talked about the different possibilities of the number of x-intercepts, right? My quadratic equation, my quadratic function can have two zeros or two x-intercepts. It could have 1 0 or it could have none, right? No real zeros. Okay, so I could have two real zeros or roots. It could have one real zero or no real zeros or roots. Yeah, could also say roots or x-intercepts or solutions, right? So it could have that. Those are the three possibilities for me. So my quadratic equation, quadratic formula helps me determine how many real roots my quadratic equation is going to have. So quadratic formula, how many real roots does the function have? Okay, so we saw in lesson 16.1, when I end up with square rooting a negative number, right? When I end up square rooting a negative number, not possible. This is not possible, right? Square rooting a negative number is not possible. So I will have no real roots. So in my quadratic formula, I have something under the square root, right? My quadratic formula is negative b plus or minus square root of b square minus 4ac all over 2a. So in my formula, I have something under the square root. So if this number is going to turn into a negative number, there is a possibility for it to turn into a negative number depending on what b, a, and c are. So it's a possibility that it could turn into a negative number. If that turns to a negative number, that means there are no real roots to my solution, to my equation. All right. So my quadratic formula comes really handy to figure out how many real roots there are to my function. Okay. So the question is, how many real roots does the function have? So whatever is under the square root, the b square minus 4ac, it is called the determinant. Sorry. It's called the discriminant. It's called the discriminant. Okay. So if that discriminant b square minus 4ac is a positive number, if that turns out to be a positive number, that means there are two roots, the plus and minus will be there. So there will be negative b plus square root of b square minus 4ac over 2a, and the other one will be negative b minus square root of b square minus 4ac over 2a, like in the problems, right? So every time we turned out to be a positive number, if that's a positive number, I will end up with two roots. One is 5 plus 7 over 6 and the other one was 5 minus 7 over 6. So I will have two real roots. They're not asking what the roots are. All the question is how many there are. So all you have to do is figure out this value, b square minus 4ac. If b square minus 4ac turns out to be greater than 0, then there are two real roots. If b square minus 4ac turns out to be equal to 0, that means this whole thing goes away. There is no possibility of plus or minus because square root of 0 is still 0. So plus or minus 0 doesn't really matter. All I have is that negative b over 2a. All right. So there is only one real root in that case. So now the third option is b square minus 4ac is less than 0. Meaning the number that is under the square root, it's turning out to be a negative number. If that's a negative number, you cannot take the square root of it. So there won't be any real root. No real root or no real solution. All right. So my discriminant helps me figure out how many real roots there will be to my quadratic function. Okay. So let's take a couple of examples to see what the discriminant are. Okay, say I have this problem, x squared x squared minus 4x plus 3 equal to 0. I want to know how many real roots there are. They're not asking me to solve it. All I need to know is how many real roots. Okay, so all I have to figure out is first put it in standard form. So to use anything from your quadratic formula, it has to be in standard form. Put it in standard form. After you put it in standard form, you will know what your A is. A is 1, B is -4, and C is 3. All you have to figure out is B squared minus 4AC. Alright, with your discriminant. This is your discriminant. Okay, I want to figure out what B squared minus 4AC is. B squared is -4 squared, minus 4 times A is 1, C is 3. -4 squared is 16, minus 12 equal to 4. This is a positive number. This is a positive number. That means when you solve this equation, you will end up with 2 real roots. Okay, so that's all they want to know, how many real roots there are. They're not asking you what they are. If they ask you what they are, then you will go ahead and solve this equation by any of the methods that you know. Alright, so all I want to know is how many real roots there are. So let's take another equation. X squared plus 2x plus 1 equal to 0. Again, this is in standard form. A is 1, B is 2, and C is 1. So I want to figure out what B squared minus 4AC is. How many real roots? That's the question. How many real roots? Okay, I want to figure out what B squared minus 4AC is. So B squared is 2 squared minus 4 times A is 1, C is 1. So B squared is 4 minus 4. It turned out to be 0. Alright, so since it is equal to 0, there will be 1 real root. 1 real root. Okay, let's take a look at the third example. X squared minus 2x equal to -2. Alright, my first step is for me to write it in standard form. So I have to bring the 2 over. So I have x squared minus 2x plus 2 equal to 0. Now my A is 1, B is -2, C is 2. Now I want to figure out what B squared minus 4AC is. B squared is -2 squared minus 4 times 1 times 2. So that is 4 minus 8, which turned out to be -4. So this is a negative number. So I won't be able to take the square root of that. So negative number, so that means there are no real roots or no real solutions. Okay, there won't be any x-intercepts for this equation. So that helps your quadratic formula, helps you figure out how many real roots there are. Okay, so that's it for lesson 16.6, solving quadratic equations by using quadratic formula. Thank you.